Thank you for joining this CS board video about YOLO NAS, a new and improved version in the YOLO models family for object detections, which can be used as a foundational model in this field. YOLO models have been around for a while now, presented in 2015 with the paper You Only Look Once, which is what the shortcut YOLO stands for. And over the years we saw various improved versions up until YOLO V8, which was presented earlier this year by Ultralytics. Now, a company called Deci has released YOLO NAS and showed it achieves great results in very low latency, with the best accuracy-latency trade-offs to date. In this video we will talk about how they were able to do that. Let's start with Neural Architecture Search, which is the meaning of the shortcut NAS in YOLO NAS name. Most of the times, model architectures are designed by human experts. Since there is a huge number of potential model architecture, it is likely that even if we reach great results, we did not nail it exactly on the best choice of model architecture out there, and we could still find a different model architecture that would yield better results. As a result, Neural Architecture Search was invented, and it includes three main components. A search space, which defines the set of valid possible architecture to choose from, a search algorithm, which is in charge of how to sample possible architecture from the search space, as there is no way to try them one by one, and an evaluation strategy, which is used to compare between candidate architectures. So in order to come up with model architecture for YOLO NAS, Deci used their own neural architecture search implementation called AutoNAC, which stands for Automated Neural Architecture Constructions. They have provided AutoNAC with the details needed to search YOLO possible architecture, which created an initial search space of huge size, and AutoNAC, which is hardware aware, found an optimal architecture for YOLO NAS, which is optimized for NVIDIA T4, in a process that took 3,800 hours of GPU. Another attribute that helped YOLO NAS reach great results in super low latency is quantization aware architecture. So what does it even mean? Well, object detection in real time is critical for various applications, such as a safe use of autonomous cars. So we want to deploy object detection models on cars, phones and more, instead of running the model in the cloud. However, edge devices resources are limited, so it makes it hard to deploy large models on them due to their size and also long inference time. Quantization in machine learning usually refers to the process of reducing the precision of model weights so they will consume less memory and run faster. This, however, many times comes with a decrease in the model accuracy. The quantization technique used in YOLO NAS is called int8 quantization, which is a way of converting the model weights from float32 to int8, so each weight is 1 byte in memory instead of 4. They were able to do that thanks to a new building block called QA-rep-VGG, which they instructed the Neural Architecture Search algorithm to include. QA-rep-VGG was recently introduced in a research paper from Meituan. We'll save the details about this building block for a different video, but in short, it is an improved version of rep-VGG block that is commonly used in object detection models that significantly improve the loss of accuracy after quantization. They also used hybrid quantization technology to apply quantization only for specific layers in the model to balance information loss and latency. Before moving on, if you like this content, then please subscribe to the channel and hit the like button, as it will help this channel grow. Let's move on to talk about YOLO NAS being a foundational model. So what a foundational model means? Say we have two different tasks at hand. One model to detect bone fractures objects in an image, and another task to detect fish objects in an aquarium. Instead of training each model from scratch, we can start with two instances of YOLO NAS, and fine-tune the first model on a bone scans dataset, and fine-tune the second model on an aquarium dataset. With this approach, we enjoy the strength of YOLO NAS pre-training that was done on very large datasets with advanced techniques, while still adapting better to specific use cases, thanks to the final fine-tuning. Thank you for watching and taking the time to learn about YOLO NAS. Please let me know in the comments section if you have specific questions about the model.